This is 2.2, solving and graphing absolute value equations. So our essential question, why is there more than one solution for an absolute value? Can you solve an equation involving absolute values? Okay, it's two questions kind of. So everything about this is about absolute values. We are going to graph some absolute values today. Hopefully after unit 1 you are good at that. Remember, they look like a V shaped, all that good stuff. But the focus, the main focus will be solving absolute value equations. Okay, so recall that absolute value of a number is that number's distance from 0 on a number line. Okay, so this is an example of looking at the absolute value of x equals 5. Finding solutions here. Okay, so absolute value is saying the x value, that number, needs to be 5 units from 0. Okay, and that's 2 places. Okay, that's why there can be more than one solution. If I move 5 to the right, so if I'm at positive 5, that's an acceptable answer. And if I'm at negative 5, 5 to the left, that's also an accepted answer, because both of those, first of all, if you took the absolute value of them, it'd make positive, but they're both 5 units from 0. Okay. So for any non-zero absolute value, there are exactly 2 numbers with that absolute value. For example, both 5 and negative 5 have an absolute value of 5. Okay. So before we move on, just to point this out, we could have 2 solutions, one solution, or no solution. Okay, 2 solutions happens if we have the absolute value of anything equaling a positive number. Okay, so just making it up. Absolute value of something equaling a positive number. If that's the case, you will have 2 solutions. One solution happens if we have the absolute value of anything equaling 0, right? If we are 0 away, that means there's only one spot where we can be, at 0, basically. So the absolute value of anything equals 0. And the last one, no solution, that is when the absolute value equals a negative number, right? An absolute value can never equal a negative number. It's by definition an absolute value always equals positive. So therefore, there'd be no solution if that's the case. Okay, these are very simplified versions, so realize that they're not the complicated one. Okay, so jump into some easy ones. Solve the equations and graph the solutions on a number line. So you're not going to actually draw a V-shaped here. We're graphing the solutions on a number line. It's kind of silly, this objective, but when we get to 2.3, when we're talking about inequalities with absolute values, that's where graphing is actually going to be important. So we're going to introduce it now, but it's going to be much more important next chapter. Okay, so how you set this up is you get the absolute value by itself first. Okay, that's always the first step. Self. So in this case, the thing in the absolute value is 6 plus k. That I want to get by itself. So I might have to divide, I might have to add and subtract things using normal solving, which we'll get to, and you'll see examples that use all that. The next step is set up 2 equations, plus and minus, okay? And then the last step is to solve both equations. And when you do that, you'll get your answers. Okay, so first step, get the absolute value by itself. That one's already done. It is by itself in this question, right? The thing between the absolute value bars is the only thing on the left side of the equation. Next, set up my 2 equations. So I have 6 plus k equals positive 13, and 6 plus k equals negative 13. All right. Put a little box around this so I realize it's not part of the work. Now we solve both equations. So I'm going to subtract 6 from both sides on the first one, and I get k equals 7. And I'm going to subtract 6 from both sides, and I'm going to get k equals negative 19. Okay, so that ends up being my two solutions. K equals 7 and negative 19. Okay, we always want to check just to make sure, because you can always plug in pretty easy and check. So I plug in, they both work. And then we have to graph. So the graph of the solution, I'll do an orange. You always put 0. That is your reference point. And then we show the thing. It doesn't have to be exact. So kind of 1, 2, 3, 4, 5, 6, 7. And this one, negative 19, all the way down there. Notice I'm not being very specific. And I'm putting solid dots on both of those. Solid dots means included. They are both included. So those are my two solutions graphed. Done. All right, next one. This one has some steps to do. First, I need to divide both sides by 3. Because I have to get the absolute value by itself first. All right, so the left side, 3 divided by 3 is 1. So that simplifies. The right side, 6 divided by 3 is 2. Now I have the thing in the absolute value bars by itself. And now I set up my two equations. Positive 2 and minus 10 equals negative 2. Notice what we're changing. It's what it equals. A lot of people want to change the minus and plus on the inside. That's never what we change. We change the what it equals. Positive 2 and negative 2. Okay? Because as long as those two things are true, we'll have an equation that works. So we'll add 10 to both sides. And I get n equals 12. And if I add 10 to both sides, I get n equals 8. If I plug back in, I'd get negative 2, absolute value is 2. Plug back in, I get 2, absolute value is 2. You can always check real quick, and you should know you have the correct answer because you plugged it in and it works. These equations are easy. I know that I have two positive numbers, so I'm kind of putting my 0 on the left side there because everything's going to be on the right. 8 and 12. Kind of make it look like it's supposed to, a little bit at least. And we have our two solid dots. Done. So, example 2. So, solve and graph the solutions on a number line, just like before. Now we have a couple things we have to do. So remember, when you're solving, you need to add or subtract first. So people have forgotten that at this point. You're not following PEMDAS. PEMDAS is for simplifying. For solving, you actually kind of use PEMDAS backwards. We add and subtract first, then multiply and divide. Okay, so now I'll divide by 2. Remember, we're getting the thing in the absolute value by itself. And we set up our two equations. X plus 9 equals positive 4, and x plus 9 equals negative 4. Okay, so we subtract. I get x equals negative 5, and I subtract. I get x equals negative 13. And so they're both negative, so I'm going to put 0 on the right side this time. So we get negative 5 about there. And then negative 13 would be way the heck down there. Notice I'm not being exact. It's estimate about where I think it would be. Okay, but it has to be on the correct side of 0. Negatives are on the left side, positives are on the right side. And there we go. Okay. And once again, you can check, but they do work. Next, we need to get the absolute value by itself. So I'm going to subtract 8. 2x plus 4 equals 8. Now that the absolute value is by itself, set up our two equations. So now we're going to have a little bit more to do with our two equations, but same exact idea. Make sure it's one positive 8, one negative 8. So I'll subtract 4. So I get 2x equals 4, then divide by 2, and I get x equals 2. And I gotta do the other one. Subtract 4, 2x equals negative 12, divide by 2, and I get x equals negative 6. Those are my two solutions, which I graph on my number lines. This time, 0 is in the middle because I got 1 positive, put a solid dot, 1 negative, put a solid dot. I know the graphs of the lines seem silly right now, but remember, this is making sure you understand this basic part, so when we get to the next section with the more complicated ones, it's not too hard. All right, next one. Subtract 3 from both sides. Wrong color. Subtract 3 from both sides. I get 2x minus 5 equals a negative 2. Divide by 2. Absolute value of x minus 5 equals negative 1. And remember, I said you had 3 cases. Be really careful about this. These steps I gave you is when it's 2 solutions. When it's, you got to check. So every example so far, the absolute value has equaled a positive number, and you follow these steps. When it equals 0, it's actually easy. You can't set up 2 equations, so you just have 1. But our last case is when it equals a negative. Okay, so be very careful about this. Don't just go through the motions. Make sure you stop and think. This is an absolute value equaling a negative number. That cannot happen, because once I take the absolute value of whatever is in the inside, it will always come out positive. So we stop here. Okay, so you don't just go through those steps every time. That is only for when it equals a positive number. All right, so let's look at the next one. So we subtract 2 from both sides. I get 2, 3x minus 1 equals 16. Divide by 2. I get the absolute value of 3x minus 1 equals 8. Oh, positive number. Set up my 2 equations. 3x minus 1 equals positive 8. 3x minus 1 equals negative 8. Then we go through our steps. So I'd add 1 to both sides. Change color first though. There we go. And I get 3x equals 9. Divide by 3. And I get x equals 3. And do the other side. Add 1 to both sides. I get 3x equals negative 7. Be careful of that. Negative 8 plus 1 is negative 7. Then I divide by 3, and the right side can't simplify. So negative 7/3 is one of my answers. Since we have solutions, we got to graph them on the number line. Don't forget that step. So 0, positive 3. So negative 7 divided by 3 is a little bit more than 2. So kind of guess where that is. And we have it. Number 3, now we are actually going to graph. Okay, they're going to give us 2 functions. They say f of x equals g of x at this. To find it, we're going to graph them. So I'm going to graph 2 functions. I'll use 2 different colors, blue for f, green for g. Okay, the first one, when I'm graphing this, it's absolute value bars. Hopefully you know it is a v. It's inside, so it's a right 2 shift with an a equal to positive 1. So right 2 from 0, 0, because that's my key point. Then follow my thing. I will tell you, you're going to want to put out points all the way on these questions. Okay, because we need to find those points. So the points actually matter in this case. Oops, that was bad. Let me reach out. There we go. It's not great, but it still works. Okay, so I'm going to label that f of x. Next, g of x, that is a y equals 2. So y equals means horizontal line that goes through 2. That's g of x. Okay, so where are they equal? That is where they intersect. And you have to be able to tell not just where they intersect, but what x values at x equals, right? Our solutions are always x values. So we intersect there and there. That is an x value of 0 and 1, 4. 0 and 4. So we just solved it graphically. We're using the graph where they intersect. That's where they're equal. Now, we're going to solve it, prove it algebraically. So f of x equals g of x. So we're going to set them equal to each other. Absolute value of x minus 2 equals 2. Okay, you need to understand how to set that up. It's pretty simple. Just set them equal. That's what it's telling you to do. Right? You follow that. And now we set it up. It's equaling a positive already. Absolute value is solved for. So set up my two equations. Add 2. And I get x equals 4. And add 2. And I get x equals 0. So I use my algebra showing my work, and I proved it is true. Okay, next one. So we're going to graph them first. So I get a value of 2 this time, so my slope is up 2 over 1 with a left 3 shift. So from 0 to 0, shift 1, 2, 3, and then up 2 over 1. Remember, you're going to actually want all the points. 2, 1, 2, 1. 1, and graph those points, label it f of x. Whenever you have two graphs, always label. Okay, next, y equals 2, right? G of x equals 2, that's y equals 2. Horizontal line at 2 happens to be the same. It will not always be the same. Okay, and we find where those intersect. We got right there and right there. What x values do they intersect at? So that's -2 and -4. Those are my solutions. The x values where they intersect. Okay, prove it algebraically. 2, absolute value of x plus 3 equals 2. Set them equal. Divide by 2 first. You get absolute value of x plus 3 equals 1. Set up my two equations because it's a positive number that they're equal to. Don't forget to check. Subtract 3 on both sides, means you're going to do it all at once. Okay, so on this first one, 1 minus 3 is -2. And on the second one, -1 minus 3 is -4. I have my same two solutions. Done. Example 4, f of g of x. So this is a little different, right? We always saw it before as f of g of x or g of f of x. So this is called a composite function, like we learned before, where we're going to plug whatever's in the inside into the one that's on the outside, right? So I'd plug g into f or f into g. So there's a shorthand way of writing this. They do this, f of g of x or g of f of x, okay? Do not multiply by x. That is telling you the variable we're dealing with. Be careful of that. A lot of people want to multiply by x. Okay, so you can see it right here. This is the setup. 2 g of f of x plus 3. So this is telling us to plug f into g. The second one into the first one. F into g. So f into g. So 2, absolute value of 4 plus x, plus 3 equals 7. Now I'll say it again. A lot of people say, well, what happened to that x? Remember, that is the format. That whole thing right here goes away. It is replaced by my new equation where I plugged f into g. Okay, so don't be confused by that and don't mess that up. A common mistake, and it really messes up the problem from that point on if you do it wrong. Okay, solving. So I get absolute value of 4 plus x equals 2. This is positive, so set up my two equations. Four plus x equals -2. Subtract 4 from both sides on all of it. and I get x equals -2 and -6. Done. We got it. Okay. It doesn't ask us to graph on the number line, so we just have that done. All right, make sure that you write your 3-sentence summary.